Hey there, welcome back. So in the last video, we saw the left view of binary tree. In this video, I'll try to cover the right view of binary tree. So let's take an example, the same example of 1, 2, 3, 4, 5, 7, and 6. So here the difference between the left and right view is here the person will be trying to see from right side, so I mean in this direction. Okay, so whatever the first node is visible to him, those nodes we should print them out. Okay, so here the output would be 1, 3, 7, and 6, because this if you see, this is what at level 0, this is what will be visible to the user, and at level 1 the 3 node, and at level 2 7th node, and level 3 6. Okay, so this is what the output should be, 1 3 7 6. Okay, so here the difference between the left and right way is, in left we try to traverse in the direction of root left and right, but here it's just swap of left and right. We traverse in the direction of root right and left. Okay, so let's do one round of traversal so that we'll better understand it. Okay, so assuming we are at initially this one, root node 1. So now since the traversal that we would be following is this one, root right left. Okay, since is there a right child for this? Yes, so we go to this 3, and now we check for, is there a right child for this? Yes. So since I said it's root right left, I'll be printing here 1, and at the same time printing here 3, because this is root. Again check for 7, again I'll be printing here 7. Okay, then check for right child, none, so we return back to its parent. Check for left child, no. And also here the same check of that level is equals to the size of resultant array remains the same. That is, this would be a level 0, this is level 1, this is level 2, and this is level 3. And initially we'll have the resultant array not is empty one. So at level 0 we check if level is equals to result dot size, which is true, that is 0 equal to 0. That is when we push 1 into this, and then when we come to the right child of it, we again check. See, if I write the pseudocode, it will be clear. So yeah, so like this we print 7. So left child not there, so go back to its parent again. So go back to its parent. Is there a left child for this? None, so go back to its parent. Now we are also again go back to its parent, 1. Is there a left child? Yes, so move to node 2. This again, this check will happen if level 1 is equals to the size of the year will be having already the 137. So I'll just write pseudocode, then you'll better understand that. So 137, this level 1 size is equals to result size, no, so we will not push this. Okay, and is there a right child for this? Yes, so I'll go back to go to the root node 5. So here level 2 is equals to the 3, or that is the size of the result array, no, so we will not push that. Now go for look for right child of 5. Is there a right child? None, so we return back to its parent. Again go for left child of it. Okay, left child. Now level 3 is 3 is equals to 3. Yes, so we push 6 into this. Okay, now is there a right child for this? No, so return to its parent 6. Again check for left child, none, so again return back to its parent. So again go back to its parent. Now is there a left child for this root node 2? Yes, So check again, 2 is equals to 4, no, so we'll not push that. Check for right child, nothing, so go back to its parent. Check for left child, nothing. So this is how the overall traversal happens of this tree. So now coming down to the pseudocode, we will write like this, okay, that is, let's name this as, right view, and here I'll pass the root node, and here the level, and here the result array, okay, something, let's say whatever it is, okay. Here base condition remains same, that is, if root equals to null, we just return, okay. And as I said, the condition, it's the parent right and left. The first condition would be is if level is equals to that resultant array size, then only we will push the current root node value into our resultant array, okay, since we want the first node of every level from right side, okay. We will push root value, okay, or else what we do, we recursively traverse the right child first, then go for its left child, okay, that is right view, root to right, and increment the level for each child, and do the same for left child, okay, that is right view, root to left, level plus 1, and result, okay. This is the simple pseudocode for our right view, okay. So now let's take the same example and see how the functions calls is happening, okay. So initially if you refer, so I will draw this tag, okay. Initially we'll push 1, so we check is it equal to null, no. Again, is level and the results are the results array size initially 0, so is 0 equal to 0, yes. So then this result array, okay, assuming this is result array, we will push 1 inside that. Again, is there a right child for this? Yes. So if so, what is it? 3. So we will push 3 inside that. Again the check will happen, root equal to null, 3 equal to null, no. So level was 1, so 1 is equals to 1, yes. So again push that 3 into this result array, okay. Now go for the right child of 3 again, so 3 right child is 7. So again check for null, no. So is level became 2, so 2 equal to 2, yes. So then push that 7 as well into our result array. Again check for the right child of the right child of 7. So is there a right child? So no, so I'll push null. So since root is equal to null, so we will return to this 7, and the same happens for the left child of 7 as well. So if I draw, so 1 3 7, so we'll go for again left child, so that is also null. So in this case also what will happen, will return. So finally this is how the stack will look like, 1 3 7. So since the exploring part of 7 is done, so that is left and right child is explored, and no more further calls in the our right view function, so that will also be taken off the stack, okay. So then this is how the stack looks like, 1 3, okay. So now go for the left child of the root node 3. So root node 3 again it is not there, that is null. We will insert null here, that is like this. So again root becomes equals to null, so we return back to its parent. So this is how the call stack looks like after this function call, that is 1 and 3. And since the exploration part of 3 is also done, we will take that also off the stack, okay. So simple, this is will be also taken off the stack. So finally we'll be left with 1, okay. 1, is there a left child for 1? Yes. So left child is 2, so push that, okay. Now check again, is level now is 1, okay, and is 1 equal to 3? No, so we will not push this 2 into our result array. Again keep on exploring the right child of the current root node we are at, that is 2. Is there a right child for that? Yes, that is 5. So we push 5 into our stack, whole stack, and check it is null. No. So is the level became 2 here. Is 2 equals to 3? No. So we will not push into our result array. We will go for again right child of it. Is there a right child for root node 5? Null. So what we do, we push null, again we return back to this. So fine, the after this the stack looks like this, that is 1, 2 and 5. Okay, so right child exploration is done. Now we check for the left child of root node 5. Is there a left child? Yes, fixed. So then what we do, we push that here, 1, 2, 5 and 6. So 6 at 6 the level is 3. Okay, so now what we check is again check for null. No. So is 3 is equals to 3? Yes, that is the size of the result array. Yeah, that is true. So we will push 6 into this. Okay, fine. So again we will explore the right and the left child of root node 6. So since both are not present, so it will be kind of like, null, and we return to this again. We push the left child as well, again null, so we return back to its parent 6, and the exploration part of 6 is also done. Finally we will remove 6 also of this type. Okay, this is how this will look like after exploring the left and right child of 6, that is 1, 2 and 5. Okay, similarly 5 exploration is also done, so that is will also be taken off the stack like this, 1 and 2. Okay, now 2, is there a left child for this? Yes, that is 4. So we push that 4 into our call stack. Again we check a level is 2 here. Is 2 equals to 4? No. So we will not push the no, 4 into our result array, and again explore the right and the left child. Right child is not there, so we push this null, again it will return to its parent. Again we check for the left child, we will push the same null, root equals to null, so we return to its parent. Okay, so after this the exploration part of root node 4 is also done, so that will also be taken off this stack. Okay, so now check for the 2. So 2's exploring also is completed, that is left and right child we done exploring, so that will also be taken off the stack. So finally this is how the stack will be, and once is also done, so that will also be taken off the stack, and that is it. Okay, so this is the rough traversal of how traversal of our function calls looks like. Okay, finally the answer we got is this one, 1376, which is exactly what we needed. Okay, so this is the traversal of right view. So now we'll go for the code part and execute this code part and check if the output is matching or not. Okay, so yeah, let's go for the code part. Okay, I have created a simple writeview.cpp file. So then first we'll import the headers, that is include IO stream and also the vector. I'll be using that vector to store our result. Okay, and then using namespace std. Okay, and then create our data type for node, name this as node. Okay, and value to store value, and left and right pointers for left and right child. Okay, left and right pointers. Okay, and then we'll create the function called right view, and here we'll pass 3 parameters. One is the root, and one is the level at which we are, and another is to store the right view. Okay, fine. First the check for always the recursion calls is base condition is very important. So if root is null, so what we do, we just return, and then the other condition what we check is if level is equals to right dot size, then only we will push that root value into our right array. Okay, that is root 2 val, or else we'll keep exploring the right child first and then go for the left side. Okay, that is right view root to right and increment the level for each child exploration and pass that right array. Okay, and do the same for left child as well. Right view root to left level +1 and same the pass the right array. Okay, so this is the simple right view function. Now and also we'll create one function to create our node. Okay, so let's name this as a new node, and the input parameter would be the value that we want to set for this node, and then allocate the memory that is needed for this node. Okay, so let me write that part quickly. So and yeah, and allocate the size of this struct node that is needed for this. So this is it, and then we'll assign the value for this node, and also assign the left and right pointers as null for now. Okay, and finally we will return this temp node. Yeah, so this is it. The functions needed for our right view is done. So finally we'll write the mean and write the same example structure and try to execute the above function and see if the output is matching or not. Okay, so let me create the root node. Okay, let's name this as a root node, and it is root node in our example was 1, and let's fastly replicate the tree structure. That is left was 2 and right was 3, and then root to left was 4, and then root to left to right was 5. Okay, and then root to left to right left was 6, then the final one, that is root to right to left, is 7. Okay, I think I misspelled here. Yeah, so this is our tree structure. Now quickly create the result array, that is right, and then call that function which we have defined above, pass the root node and level as 0, and pass this right array. Okay, and then once the call is done, we will print the result. Okay, that is, let me write as right view, something like this. Okay, and now let's traverse the right array and print the content in that. Okay, so and let's check what is its output. Okay, so this is the simple function, so let's execute and check what is the output. Yeah, see, the right view is 1376, which is exactly what we got while we were exploring the example. So yeah, so this is it for this right view traversal of a binary tree. Keep looking for more videos on this channel. Thank you.